Both types of waves involve transfer of energy without transfer of matter. While mechanical waves travel through matter, the waves themselves don't move matter to a new place. They just move energy. The waves are disturbances in matter that transfer energy. Okay. So from this paragraph, waves transfer blank. Waves do not transfer blank. So what do they transfer and what do they not transfer? Waves transfer energy. That's our primary definition of waves here. So transferring energy from one point to another. Waves do not transfer matter, so that matter stays where it's at. And we're going to see that in pictures as we go forward here a little bit. A vacuum is completely empty. Why is the space around you not considered a vacuum? Right? Write down some examples of waves that you are familiar with in everyday life. Can you classify them as mechanical or electromagnetic? So let's start with the first one. A vacuum is completely empty. Why is the space around you not considered a vacuum? What observations can you make to support your claim that the space around you is not a vacuum? The space around me is not a vacuum because there's air everywhere on Earth. I can feel the wind on my face. I can hear sounds which require a medium to transfer through, we've already learned. If a vacuum were present, there would be no air to brush against my face. I wouldn't be able to breathe or hear anything. Also, things like a balloon fill up with air, showing that there's space around us has particles in it. Let's write down 3 examples of waves that you are familiar with in everyday life. Can you classify those as electromagnetic or mechanical? Okay? I'll give you a minute to write those down. So I've given a bunch of different examples that you guys may be familiar with, right? Any 3 of these is fine. So we're talking about light, that's electromagnetic. Microwaves, you have a microwave in your house, that's electromagnetic. Radio waves, right? Radio in your car is electromagnetic. I don't know if we're still using radios in our cars as often as we were when I was a kid. Ropes, when you wiggle it up and down, that's a mechanical wave. Seismic waves or earthquake type waves are mechanical. Waves on a slinky, you guys have seen the slinky in my room, right? Those are mechanical waves. You can make both transverse and longitudinal waves with that. We'll talk about that in a little bit. Sound waves are mechanical waves, so what I'm doing right now is moving air molecules back and forth, wiggling them in a specific frequency pattern so that you can hear it. A tsunami or a huge wave, that's a mechanical wave. And waves on the surface of water are also mechanical. So here's our first. We got a transverse wave can be classified by how energy is transmitted. Energy is transmitted through medium by mechanical waves. Electromagnetic waves are capable of transmitting energy through empty space. A transverse wave is this sinusoidal pattern that goes up and down. Sinusoidal is from the math term sine, or this curve that you see here going up and down, okay? So, our question, electromagnetic waves can move blank through empty space. What can they move through empty space? Right? They move energy through empty space. Waves can also be classified by how particles in the disturbance vibrate. A mechanical wave that begins when a source of energy causes a medium to vibrate. The direction of the vibration determines the type of mechanical wave produced. A transverse wave is perpendicular or at right angles to the direction of the sources of motion, right? The person in figure 2, so we got this guy in the gym, he's wiggling his weight ropes up and down. He's using his arms to make up and down vibrations into the ropes, right? Each particle of the rope moves up and down the direction he is producing through, right? Is the direction of the wave he is producing, though, is perpendicular to that up and down motion. The energy is traveling towards the far end of the rope. So he is moving his arms up and down, but the waves are moving this way. The energy is traveling this way, okay? So we've got motion going up and down, and at a right angle at 90 degrees or perpendicular is the direction of the travel of the wave, okay? Transverse waves travel blank to the motion of the source. They travel perpendicular to the motion of the source. The curved shape of the ropes indicates the main features of a transverse wave. The high point in the wave is called the crest, right here, right? The low point in the wave is called the trough. The distance between the highest crest and the resting point or the midpoint of the wave is called the amplitude. So the equilibrium is the resting point, right? Equilibrium. And the amplitude is measured from crest to rest, okay? The distance, in general, amplitude of the wave is the maximum distance the medium vibrates from the rest position. So, in this series here, which of these is the crest? Which of these is the trough? And which of these is the amplitude? So, our crest is this first one with the point at the peak at the highest point here. The trough is the one where the red point is at the lowest point. And the amplitude is when we measure from the rest point up to the crest. Electromagnetic waves, such as sunlight, are also example of transverse waves. In their case, however, there's no motion of particles, even when the light travels through a liquid such as water or solid such as glass. Interesting. Electromagnetic waves are classified as longitudinal waves, mechanical waves, sound waves, or transverse waves. Select the one that's correct. That is incorrect. Electromagnetic waves are transverse waves. I highlighted the wrong one there, so please make sure you get the transverse waves.